While Juno's spectacular views can only be achieved from orbit, from down here on Earth we get the bigger picture. Here's Pete to show us how.
Well, I had hoped to bring you a view of Jupiter through my telescope tonight, but as has been the case over the last few weeks, the sky has completely clouded over now. If you're wondering where Jupiter is, then it's rising in the east-southeast during August as the sky is getting darker. It's a really bright object down there. The problem is that looking at a planet when it's low down, for example, just after Jupiter has risen, will give you quite a wobbly view of it because you're looking through a thicker layer of atmosphere. The best strategy is to wait until Jupiter gets to the highest position in the sky, and that's due south. Mid-August, that occurs around about 1:30 BST, and at the end of August, it's about midnight. Jupiter comes to opposition on the 20th of August, and that's the time when the planet appears brightest and largest when you see it through the eyepiece of a telescope. Now, the weeks leading up to opposition and after opposition will give plenty of fine views too, so there's lots of time to take this planet in. If you have a small telescope, you'll immediately see that the disk looks flattened at the poles, and that's a consequence of Jupiter's rapid rotation. You should also be able to make out the two largest belts. That's the North Equatorial Belt and the South Equatorial Belt. They run parallel to the equator. Nestled in the southern edge of the South Equatorial Belt is that long persistent storm, the Great Red Spot, but you'll need a telescope with an aperture over 4 inches to see that. Larger telescopes will pick out even more detail, more belts, more zones, bright spots, dark spots, and lots of other structures on the edge of the belts and zones. So there's plenty to see there. Now, as well as all this detail, Jupiter has a large family of moons, but only 4 are easy to see with a small telescope. And these so-called Galilean moons are quite interesting. And to demonstrate some features about them, I've made a model. Bear with me a second. There we go. So this is my model of Jupiter. If I bring you in a bit closer, you can see the main disk in the center here, and you can see the 4 Galilean moons either side of Jupiter. Now, this is quite a reasonable model because it shows what the moons sort of look like through a small telescope. And as they orbit round Jupiter, you see the moons moving around the planet. Now, various things can happen. For example, the moon can move behind Jupiter and then it gets occulted by the planet's disk. Or, depending on the geometry of the situation, it can move into Jupiter's shadow, and that's called a moon eclipse. Another effect occurs, if I can demonstrate this, I'll steal a moon for this one. There we go. As the moon moves in front of Jupiter, so its shadow falls on Jupiter's disk, and that creates what's called a shadow transit. And there will be quite a number of these over the up-and-coming observational period. But an interesting thing is happening with Jupiter at the moment because the planet has just gone through what's known as an equinox. That's when the sun appears on Jupiter's equatorial plane. I can simulate this by dropping the camera down like so that we're looking along the equatorial plane of Jupiter, more or less. And that means that as the moons go round the planet, they can interact with one another. So you may get one moon which covers another, or you may get the shadow of one moon eclipsing another. And these are called mutual events. And over the coming weeks, there'll be a number of these mutual events to look out for.
For details of upcoming interactions and advice on how to view what promises to be a spectacular Perseid meteor shower in the next few days, visit the Sky at Night's website to watch this month's star guide.